Okay, we're getting ready. I have some updates. Let's go. Let us go. Why are we on the wrong desktop? Hold on. Not sure why it's showing the wrong desktop. There we go. That's the right desktop. Okay, welcome everybody. Let us start today. So, few things. Let me turn down the music. Actually, oh, something's wrong. I'm not. Give me 1 second. That's not what I intended to happen. Let me. Where's main? Yeah, I'm in main. Rhythm box. Okay. Oh, yeah, it's the wrong item. Okay. So that should work. Let's see. Actually, that's not going to work like I want it to. So we're just going to not do the music for now. But let me, you know what I can do is just cancel this one. Yes. Go in here. I'll pick a music file. I don't know which one it's going to be. Let's see. We'll do this one. Hopefully this is pretty good. See you in a minute. It's pretty loud. Okay. Let me monitor it so I can see exactly how loud it is. Monitor and output. Okay. Yeah, that doesn't sound bad, does it? Yeah. Okay. Seems like some good background music to begin. Okay, so as you can see, I don't know if you could tell, I did get a new webcam. I hope it's a little bit clearer than my existing webcam. I got the Brio 101, just the recommended entry-level zooming webcam. It's supposed to have really good like autofocus for stuff like that though. So let's see, does it work? Not as well as I wanted to, but maybe we'll investigate it a little bit more and see if we can get it working well. So let me. I do have the background music monitored for right now. I'll monitor it until someone tells me it's too loud, and then I can turn it down a little bit if it is too loud. So let's start. So let's pick up where we left off last week, which was right here on the pointer arithmetic, the array equivalents within function calls, and then the void pointers and examples of how to use the void pointers. So we're just going to dive right into the example here. Let's write our own memory copy to try this out. We can copy bytes, and we know the number of bytes because it's passed in. Right there at the beginning, we copy the void star voids into the char pointer so that we can use them as char. It's as easy as that. Then some fun in a while loop where we decrement byte count until it becomes false. Remember that with post decrement, the value of the expression is computed for a while to use, and then the variable is decremented. Yep. And some fun in the copy where we assign pointer D equals dereference S to copy the bytes, but we do it with post increment so that D and S move to the next byte after the assignment is made. Yep. Lastly, most memory and string functions return a copy of a pointer to the destination just in case the caller wants to use it. Now that we've done that, I just want to quickly point out that we can use this technique to iterate over the bytes of any object in C, floats, structs, or anything. Let's run one more real-world example with the built-in QSort routine that can sort anything thanks to the magic of void pointers. In the following example, you can ignore the word const, which we haven't covered yet. Okay, so let's go ahead and implement this example here. So let's just open up our source. I did update my Emacs a little bit too. We'll talk about that when we get to that portion of the whoa, that's not what I wanted to open. Not at all. I wanted to kill the animal buffer. Actually, I wanted to open a deer there, didn't I? Okay, there we go. Okay, so we have all of these in here. I'm actually going to make a new directory because we're going to start creating little make files. I was reading up on the make documentation today, and I want to start using that. It's a simple way to build something, make sure it's good to go, no pun intended, and it's a whole lot easier than have to type in your compile command every single time. We can put them as targets, and you can have variables inside of make. So we'll do that and then use that as an example. So this, let's call this folder, what are we doing? We're doing void pointers, right? Void pointers. Okay, so we'll go in there and then we'll just find main.c, and there we go. And then let's include our standard C stuff that we need. This one looks like it needs a standard library as well. We'll look at the documentation for that in just a minute to understand really what that is. And then they have a struct. They have an int compare. Of course, we're going to need a main as well. So we'll do that. Main void return 0, right? And let's just printf hello world. Like that. And then we'll save that, and then we'll also find a make. Is it just gonna be make? And do we have make mode in here? Make mode. Fly make mode? No. Make fundamental H. Okay, so we can say our C flags equal wall extra pedantic and G, and that's and standard C89, right? And then we could say main depends on main.c, and that's going to call C flags like this. We're going to do this C flags and then -o main.c -o main.c to -c main.c to -o main, right? And then that should be good for right now. Let's go back to our C and we'll compile. This time we'll just do make. No make file found. Oh, is it not supposed to say save alternate save alt Save as. Save buffer. Oh, not that buffer. We gotta go to make, and we want to save it. Let's just go to D, G, and we need to move Dirid move, Dirid do move, copy make to make file. Okay. Yeah, so that was the right thing to do. Let's kill this one then. And I wonder if there's a faster way to delete variables than doing it that way. Okay, so that has our make now. We'll save it, go back to our file, and then let's recompile. Compilation code. Missing separator. Stop. Missing separator. Okay. And missing separator. Okay, so let's go look at the documentation. So let's look at GNU make manual. Okay, it's off. It's a white. I apologize for that. Let's look at the introduction. A simple make file. Yeah. Okay. So edit. Oh, we want to have. Okay, that root file is main O, and main O does main.c. Okay, so let's do. We'll do main requires main O. And let's insert, no, and that's CCO main. That's it. Okay. And then main O, whoops, main O requires main.c. That's CC C flags. CCC flags main.c. Oh, that's it. Main.c. Let's go back to this file. Compile. Missing separator. What is a missing separator? I didn't separate? Oh. Is that the separator? Is that what they mean? Yeah. That's what they mean. Recompile. Error. Unrecognized command line option pedantic. Did you mean pedantic? I did mean pedantic. Yes, I did. Past last error. Make file. I always spell pedantic wrong, don't I? Pedantic. Okay. Go back to the main. Recompile again. Fatal error, no input files. Fatal error, no input files. I did give you input files. Go back to the make file. CC. Where's my input files? You don't see them? I guess I don't need this object file right now because we're not doing that quite yet. So we'll just do this. And main requires main.c. cc flags.c. cc flags. Yeah, what? Main.c, cc. We split long. Main.o. We're doing the main. We're doing main over here, folks. Main.o insert cc edit -c main.c with the flags. Yeah, right. Next. Introduction. Yep, how to process. Variables make it easier. So I have the objects. And then you do that with the flags. Objects equals, okay. Deduce the recipe. Yeah. Another style. Main to main.c. What is the C? Main to main.c, right? Yeah, okay. So, why did background music stop? It doesn't loop? I thought it looped. Okay, there it goes again. Compile. Oh, it's GCC, not CC. But I don't know. Cannot find main. Oh, it's main.c. Oh. Main.c makes main, right? Doom, doom, doom. Bum, 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 bum. No, no such. Huh, what am I doing wrong here? Could be that it's... Okay, so... int main return 0. What is the... Oh, extra pedantic G standard. Main... Cannot find main. isn't it? So hold on, let me go back to here. If I just do GCC main.c. Yeah, what? Void pointers, I'm not even gonna get there today. Okay, so oh, come on, Keenan. It's the out. Out. Bum, 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 bum. Is it? But I thought, where's the thing for replay buffer? One second. I'm checking something on my OBS. Shoot. Every time I try to move Super R. Okay. Output. Where I don't see what's super R. Is it really doing it though? Hold on, I need to open files to see if these replays are showing up. No, see? Videos? No. Give me one moment here. So I have it opened saying that the replay buffer should be recording path. Oh, just recording path is just. That's not good. Yeah, no, I don't. Huh. I'll have to look at that later. Okay. Let's get back to... There we go. Now I got the make. Okay. Okay, cool. Now we can add a... Whoops. Oh, excuse me, I apologize. Now we can ask a objects. Objects are main.c. Oh, and then I just do clean. Oops. We could do clean, which is a phony. Okay, then we go to this part here. Objects. OBG. OBJ equals main.o. Main.o. C flags. Main. Let's see. That's all. Main.o. Main.o. Yeah, we can put that options in there. Come on. It's not my first day. Dang, I can't type though, I guess. Oh. OBJ. Dun, 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 dun. Oh, let's edit. Oh my god. I just literally typed edit in from the tutorial. Yeah, I'm sure about that. Yeah, I'm aware you can't. Okay. Let's go back to the terminal now. Take a look at what we've done. RM edit. Okay, now we can clean. Now we can clean. Yeah. Now we don't have any. No, why is the main O still there? Is this supposed to remove the objects? Oh no, it's not, because we never said that, did we? We did not say to remove the objects, did we? But we are going to now. OBJ. Oh. Okay. We're getting an understanding how make works. Now we can compile, clean, main, no such file directory. Understand. What is there now? Nothing's there now. Good. Compile. Now we just make. Cannot use executable file as input to a link. Okay. So this is doing it. Oh, though. What? Yeah. Why is it doing an O? Does it need to do an O? But why is an O being created in the first place is my question. Why is an O being created? Oh, because I put that it requires an O. It doesn't require an O. Not at all. It literally requires C. Okay, now there's no O. Okay. Now there's no O. Okay. Yeah, it doesn't need a extra linker. Okay, back to the thing. Alright, so we created that. There's a struct that we're going to be using for an example to copy. The struct that we are going to do something with. Fun, fun, fun. Okay, so struct char star name int leg count type def animal. Is that right? Is that the right way to do a type def for struct? Guess we can find out. Recompile. No. type def. There we go. Well, let's go back to the contents where we were first learning about the structures, because I thought declaring struct initializer, declaring a structure. Dun, 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 dun. 8. What's after 8? Type def, there we go. Structs. Type def struct. Oh, you do put the struct at the top. Okay. I'll remember that now. I think. Okay, let's get back to where we were. There we are. Meta D. How come Meta D is operating like that? What the heck? Okay, so we need to visit the edit. No keyboard macro. Control C, edit. There we go. So where is that? Where is that function for delete whole word? There it is. Yeah, backward word. No, not meta. The backward word, kill word. What if we're already at the beginning of a word, though? Maybe I might want to not. Okay, so then I can meta delete it. Yeah. Okay. There we go. That recompiled. Okay. Meta D did do back, so I'll have to figure out if I like that or not. Chart animal. This is comparison function called by qsort to help it determine what exactly to sort by. We'll use it to sort an array of struct animals by leg count. Okay. Are we now? Let's do it then. We'll use it to a struct of animals. So int compa. He said don't worry about the He said don't worry about the constant keyword quite yet, so we won't worry about it. Return 0 would be a good return. Okay. And we're going to do constant struct animal. Constant animal, right? Say animal. Animal pointer equals ln1. Pointer 1, animal pointer 2 equals element 2. Return less than 0 equals 0 depending on whatever we want to sort by. Let's sort ascending by leg count, so return the difference in the leg counts. Okay, so that's like the compare interfaces of some languages. So if animal, the leg count is greater than animal 2, oh, I gotta do animal 1. Animal 2, the leg count return 1. If animal 1, the leg count is less than animal 2 leg count, return -1. And if they're the same, we just return 0. Okay. That's why there's a return 0 there. Okay, and then our int main void function, build an array of 4 structs with different characteristics. This array is out of order by leg count, but we'll sort it in a second. Okay, so animal 4, animal A, 4 of those animals equals oh, I don't think you were allowed to do that in C89. So what am I going to do if we weren't allowed to do that? If we weren't allowed to do a thing in C89, then how do we get by a thing that we weren't allowed to do with that thing in C89? Let's figure it out. We're gonna figure it out, folks. Let's figure it out. Figuring things out today. Bum, bum, ba, ba. La 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 la, da da la 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 la. Okay, so struct animal. I think we're going to say dot name dot leg count. Let's do it, but I don't think we're allowed to do that in I don't think we're allowed to do that quite yet. 4. Warning: forbid specifying a sub-object to initialize. Warning: forbid specifying sub-object to initialize unused variable. Yeah. So I think with C89 we have to just do like that. Like that. I think. Yeah. Yep. So that's fine. I mean, if you're working with it, I suppose you would know anyways if it's your API. It's my API, so. And for right now, I'm gonna do C89 stuff. If I find that I want and need these other things, then I'll upgrade to those at that time. Okay. So now we have that. Now we're going to sort. And that's where the Q sort. Okay, so let's look at the documentation for Q sort. Can we do it info? Are we able to look at info documentation for stuff like that? So if I do Control H, info. Returns here, each gives a primer for the first timers. Okay, so do we have CLib, GCC, C library, program, CLib, lib. Let me look here. What are we looking for? Standard lib? No. Qsort? No. Okay, so we're gonna have to do that at a later time. Let me look. Let's open up another, that one, and then so we can use that to like look at documentation. So man qsort, sort an array. Qsort function sorts an array. Okay, include standard lib.h, and I need libc for that to work. Qsort function sorts an array with elements of size. With memory elements of size. The base argument points to the start of the array. Are sorted in ascending order according to comparison function pointed to by compare, which is called with two arguments that point to the objects being compared. The comparison function must return an integer less than equal to or greater than 0. Function doesn't accept that comparison takes a third argument. A pointer is passed via arg. In this way, the comparison function does not need to use global variables passed and is therefore reentrant and safe to use in threads. Words in words. Words in words. Okay, so qsort a for size of animal compare. Print them all out. For I need an int. For whoa. For I equals 0, I is less than 4, I plus plus, print f, integer, then the string, new line, we're going to print the ith, items leg count, and ith, items name. Okay, recompile. Yeah. Okay. That works, so let's run it. Zero snake, 2 monkey, 4 dog, 4 antelope. Huh. That's very cool. Wow. Very nice. Very, 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 very nice. I have to say. I liked it a little more than last time. So, means tell exactly what to sort this data. We'll do that inside the compare. This call is saying qsort array, which has 4 elements, and each element is size of struct animal bytes big. And this is the function that will compare any 2 elements. Let's duplicate the tab because I like his. Let's go to the guides on the library. Whoa! I don't know why it. Yeah, there we go. And when I go HTML, then it does. It's weird that operators. Where are we? We're standard lib. Standard lib. There we go. Okay. So it takes the base. This function will quick sort or some other sort, probably speedy, an array of data in place. Like bsearch, it's data agnostic. Any data for which you can define a relative ordering can be sorted, whether int, s, structs, or anything else. Also, like bsearch, you have to give a comparison function to the actual compare. Base is a pointer to the start of the array to be sorted. Okay. NBM is the number of elements in the array, number of members. Size T is the size of each element. Compare is a pointer to the comparison function. The comparison function takes pointers to 2 elements of the array as arguments and compares them. It should return a negative number if the first argument is less than the second, 0 if they are equal, and a positive number if the first argument is greater than the second. This is commonly computed by taking the difference between the first argument and the second if subtraction is supported. Okay. As long as you give a qsort a function that can compare 2 items that you have in your array to be sorted, it can sort anything. And it does this without needing to have the types of the items hard-coded in there anywhere. Qsort just rearranges blocks of bytes based on the result of the compare function you passed in. Okay. But then we could implement our own sort function, which would probably not be the easiest thing in C, but be a fun thing in C. Okay, so very interesting. Very interesting. Let's try a real-world example. It's built-in qsort because this is a comparison. We use it sorted array. Okay. Next is manual memory allocation. This is one of the big areas where C likely diverges from languages you already know. Manual memory management. Other languages uses reference counting, garbage collection, or other means to determine when to allocate new memory of some data and when to deallocate it when no variables refer to it. And that's nice. It's nice to be able to not worry about it, to just drop all the references to an item and trust that at some point the memory associated with it will be freed. But C is not like that entirely. Of course, in C, some variables are automatically allocated and deallocated when they come into scope and leave scope. We call these automatic variables. They're your average run-of-the-mill block scope local variables. No problem. But what if you want something to persist longer than a particular block? This is where manual memory management comes into play. You can tell C explicitly to allocate for you a certain number of bytes that you can use as you please. And these bytes will remain allocated until you explicitly free that memory. It's important to free the memory you're done with. If you don't, we call that a memory leak, and your process will continue to reserve that memory until it exits. If you manually allocate it, you have to manually free it when you're done with it. So how do we do this? We're going to learn a couple new functions and make use of the size of operator to help us learn how many bytes to allocate. In common C parlance, devs say that automatic local variables are allocated on the stack, and manually allocated memory is on the heap. The spec doesn't talk about either of those things, but all C devs will know what you're talking about if you bring them up. All functions we're going to learn in this chapter can be found in standardlib.h. Allocating and deallocating, malloc and free. The malloc function accepts a number of bytes to allocate and returns a void pointer to that block of newly allocated memory. Since it's a void pointer, you can assign it into whatever pointer type you want. Normally, this will correspond in some way to the number of bytes you're allocating. So, how many bytes should I allocate? We can use sizeof to help with that. If we want to allocate enough room for a single int, we can use sizeof int and pass that to malloc. After we're done with some allocated memory, we can call free to indicate we're done with that memory, and it can be used for something else. As an argument, you pass the same pointer you got from malloc, or a copy of it. It's undefined behavior to use a memory region after you free it. Let's try. We'll allocate enough memory for an int and then store something there and then print it. Allocate space for a single int. Int pointer equals malloc size of int. Pointer 12, store something there. Print it. Dereference P to 12. Print the reference of P. Free. All done with that memory. Error. Undefined behavior used after free. Now in that contrived example, there's really no benefit to it. We could have just used an automatic int and it would have worked. But we'll see how the ability to allocate memory this way has its advantages, especially with more complex data structures. One more thing you'll commonly see takes advantage of the fact that sizeof can give you the size of the result type of any constant expression. So you could put a variable name in there too and use that. Here's an example of that, just like the previous one. P is an int, so same as size of int. Int star P equals malloc size of star P. Okay. Error checking. All of the allocation functions return a pointer to the newly allocated stretch of memory, or null if the memory cannot be allocated for some reason. Some OSs like Linux can be configured in such a way that malloc never returns null, even if you're out of memory. But despite this, you should always code it up with protections in mind. Int pointer x equals malloc size of int times 10. If x equals null, print error allocating 10 ints. Do something here to handle it. Here's a common pattern that you'll see where we do this assignment and the condition on the same line. If x equals malloc equals null, print error allocating 10 ints. Do something here to handle it. Okay. Because that's the pointer. Okay. Allocating space for an array. We've seen how to allocate space for a single thing. Now what about for a bunch of them in an array? And C, an array is a bunch of the same thing back to back in a contiguous stretch of memory. We can allocate a contiguous stretch of memory. We've seen how to do that. If we wanted 3,490 bytes of memory, we could just ask for it. Char pointer malloc 3490. Voila. And indeed, that's an array of 3,490 chars, aka a string, since each char is 1 byte. In other words, size of char is 1. Note, there's no initialization done on the newly allocated memory. It's full of garbage. Clear it with memset if you want to, or see call alloc below. But if we just multiply the size of the things we want by the number of elements we want, and then access them using either pointer or array notation. But we can just multiply the size of the thing we want by the number of elements we want, and then access them using either pointer or array notation. Example. Include standard input dot, standard lib, int main, allocate space for 10 ints, assign them values 0 through 45. Print all values. Free the space. Yeah, because that's the, yeah. Okay. I want to do this one because this one's a good example. Let's do memory allocation, mem_alloc. Main.c. Wait, what? No, I don't want valid pointers. I want to... Okay. And then standard lib, include standard input.h, include standard lib .h int main void return 0. Okay, so we're going to allocate the memory. Allocate space for 10 ints. Equals malloc size of int times 10. Okay. Assign them values 0 to 45. For I equals 0, I plus p I equals I times 5, and then print the values. For I equals 0, I is less than 10, I plus plus, printf rd and p I. Okay, now I can just go to the make file. There's the make file. There we go. And I just need the whole thing. It's the same thing, right? Okay, so I copied that back here to main compilation make file. No, I didn't want to go to that one. Ah, man. Mem compilation make file. No. I want to make a file. That's weird. No. I don't. So that's the thing with this. Okay. Very interesting. I want to create a file in here. Make file. There we go. Then I can put that in there. So I just have to do it fast, because if you don't do it fast, there's that delay. And it goes back to that other thing there. So, okay. Oops. Okay, make terminated include D. I don't know why I was doing that. There we go. Okay. Well, now we need to go to mem, alec, and then main. Cool. And then oh shoot! Memory leak. I never freed it. Oh no. How do I fix a memory leak? Did I add it? Huh. I never freed it. What happens if you don't free? What happens if you don't free? Oh, really? Okay, cool. Thank you. Thank you, the Jinx 2011. I didn't, it's the first time literally, that was the first code I've ever written for memory allocation. So, you know, I've been a object-oriented programmer for forever. So the OS will free it because is it because the OS frees it because that page file that was allocated to that program is cleaned up, like the process isn't running, so they get rid of that page file or something? The host OS will free the space. Okay. The key is that malloc line. If we know each int takes size of bytes to hold it, and we know we want 10 of them, we can just allocate exactly that many bytes. Yep. An alternative calc is another allocation function that works similarly to malloc with two key differences. Instead of a single argument, you pass the size of one element and the number of elements you wish to allocate. It's like it's made for allocating arrays. It clears the memory to 0. You still use free to deallocate memory obtained through calloc. Here's a comparison of calloc and malloc. Allocate space for 10 ints with calloc, initialized to 0. Allocate space for 10 ints with malloc, initialized to 0. Again, the result is the same for both, except malloc doesn't 0 the memory by default. Okay, the Jinx. I see what you're saying. Yeah, something to that extent. That's what I figured. I was watching the Handmade Hero series with like Casey explaining memory and the C initial thing. I have on my to-do list to sign up for his Computer Enhance, where they completely walk through all of that low-level stuff. But my understanding is that, so I'm glad you verified that while the program is running, if you don't free it, that's when you run into problems. So like if I had this in a loop and it was consistently allocating, you know, hundreds of bytes, thousands of bytes, and just kept on looping through it and not freeing it each time, then it would just, that's essentially what a memory leak is, right? Yeah, I think there's a bit of a delay. I'll have to see when your messages come through. Thanks for tuning in, by the way. about to end this stream for this evening, but if you like this kind of stuff, feel free to tune into my schedule and join along. I'm learning C through like the Beach Guide and playing with some stuff, and then eventually, after a few more chapters of this, I'm actually going to start throwing some code down and make some projects. Thinking about making like a cool incursus based timer, kind of like a screensaver based like incursus timer, and then a few other kind of utility tools to kind of practice the low level stuff, and then maybe build like a game or something like that eventually. But yeah, thanks for joining in. Changing allocated size with realloc. If you've already allocated 10 ends, but later you decide you need 20, what can you do? One option is to allocate some new space and then memcopy the memory over, but it turns out that sometimes you don't need to move anything, and there's one function that's just smart enough to do the right thing in all the right circumstances: realloc. It takes a pointer to some previously allocated memory by malloc or calloc and a new size for the memory region to be. Yeah, thanks, man. Thanks for the sub. If you have a channel too, I'll check it out too. Yeah, I like the Beach Guide. I think that it's pretty nice. What's also nice is his reference documentation. So along with the guide that teaches the first programming, and then he does like commentary essentially on all of the library functions for like the standard lib, for the base package. So that's kind of nice. Yeah, I appreciate the sub though. I'm going for 100 subs, and then that's when I want to. I'm hoping by then I have enough, but that's when I want to make like a little like splash screen or something like that. I might do it like with Python. I've been programming in Python and C#, JavaScript for a very long time, so I could just make something simple like that. But I really wanted to understand the low level stuff. And just kind of enjoy programming. Like, this is fun. It's not like stressful. My day-to-day work stuff is sometimes fun, but it's also stressful. In an enterprise environment, there's a lot of red tape, organizational policies, which I understand them. I'm not calling them red tape like it's necessarily bad, but it's red tape to protect the whole organization. There's a lot of stuff you have to go through before you get a line of code on, and then the company's bought into certain technologies and not others. Then grows or shrinks, returns a pointer to it. Sometimes it might return the same pointer if the data didn't have to be copied elsewhere, or it might return a different one if the data did have to be copied. Be sure when you call realloc, you specify number of bytes to allocate and not just the number of array elements, that is. Num floats is 2. MP. Okay, yes. Let's allocate an array of 20 floats. Oh, I can imagine. I can imagine with government. Two of my best friends work in the government, so totally understand what you're saying. Be sure you call realloc, specify. Let's allocate an array of 20 floats and then change our mind and make it an array of 40. We're going to assign the return value of realloc into another pointer so we can check if it's null. If it's not, then we can reassign it into our original pointer. If we just assign the return value directly into the original pointer, we'd lose that pointer if the function returned null, and we'd have no way to get it back. Yes, yeah. we just reassign the return value to the original, then we'd lose that pointer if the function returned null. Yep, okay. Allocate space for 20 floats. Assign them fractional values. Well, wait, let's actually make this array an array of 40 elements. New p. Okay, so you're getting a new pointer, realloc, passing in the previous pointer, size of p times 40. So we're growing it. We're not adding additionally, we're growing it. So it's doubled the size essentially. Check to see if we successfully reallocated. If new p is null, print error reallocating, return 1. If we did, we can just reassign p. Okay. Alright. And then p equals new p. Okay. So we essentially overwrote and assigned the new element values in the range 1 to 2. Because I starts at 20 now. Okay. So we're looking at the 20th pointer element because we resized it. Wow. Whoa. Okay, so... Oh, I wonder what that's doing under the... I wonder if that's way more efficient than like in... Let's, for instance, look at it like a JavaScript or any of those object-based languages that reallocation or resizing an array is not an easy thing. Not an easy thing. Well, depending, I suppose, right? It depends where the items in the array are. If you have items at the end of your array and resizing them. That's very interesting. Okay. Now we print all of the elements. Now we free it up. Notice in there how we took the return value from realloc and assigned it into the same pointer variable p that we passed in. That's pretty common to do. Also, if line 7 is looking weird with that size of in there. No, why would it be looking weird? Size of pointer times 20. Because it's not a built-in type, so you don't need to wrap it in. So my understanding for him, so I want to take the understanding, is that when you use size of, you can use it as a, so we could use it as, it's an operator, it's not a function. The only time you have to put it into parentheses is if you're passing in built-in types, because those are keywords, right? So I can't do size of that because that's operator on a type. It doesn't make sense, right? But this one is saying, you know, what is the size of that type? So size of can be used with custom types all day long, and you don't need to put anything in there, or variables. If it's built-in types that you're getting size of, like a char, or you know, uint or something like that, then you have to wrap it in parens. Allocate space for 20 floats. I might write a script to test that out at some point to see, because I want to see, like, especially languages that I know for sure. It depends too in the underlying structure. So I'm talking specifically. Yeah, because they have to make a copy and then copy it over because the memory is more constrained with like the object, because the object, all of the memory partitions for an object are probably are very close to each other in memory. And here I am wondering if you call realloc or something, it might. have faster way, or you know, be able to push, you know, just point, find a spot in the virtual page, in the system page. I could find a spot. So say it gave you a spot of 20, and then you say, okay, now I want a spot of 1,000. And it could be, okay, it's not really near me, but it could just say, take that original pointer, or return, you know, a new pointer to a spot that's 1,000. So here's your new thing, and then you just apply that old pointer like you did on line 7 to that new one, and then you could just write. No, that doesn't make sense either. Man, this is fun. This is fun, questions like this. Okay, so I think that's going to be it for me tonight. I need to get some stuff taken care of. I was going to do some more Emacs customizations. We can look real quick at my current ones right now. So let's do, we'll visit my file, the org file, and then let's open everything. Okay, so let's open everything. There we go. So I have settings for the terminal, obviously a SpaceMac theme. There's the stuff that I don't want to be asked yes or no, just yes. The global subword mode is so when you're, like, for instance, with C or things like that, and you have type names that have multiple words in them, you can jump between subwords very easily. Now, the delete whole word right here, that was giving me a little bit of issues today. I think I might want to set the global key to something else, because if we go back, look at one of the buffers, actually let me cancel, let me just split the screen, and then we can go look at a buffer in there. So maybe I can use this one as example. So let's say I'm in here and I make a, I don't know, int some large word var here, right? So with subword now, when I go back words, it's going to go back all the subwords, right? And if I had turned off the subword mode, so if I turned off the subword mode, let me turn off subword mode just so you know. Subword mode. So now it's disabled for the buffer. So now when I go back, it could go back the whole word, right? So if I wanted to just say if I wanted to change some large, now I don't have that ability. So some word mode, I think it's beneficial because you only have to go back a few times to get to the words. So what that function allows you to do is to go, when you do meta delete, it will go without the function that was created, it will go and just delete this, would leave var here instead of some large word. But if I do meta delete, I can get it to do like the subwords, so it's doing all of the words. Now the problem is with it is if I do it again now, it's going to do that int, so I don't really like that. So I think I want to go up to here, and I don't want to lose my original meta delete functionality, so I'm going to do Control C for this, and WW for kill whole word. So Control C, then WW for the kill the whole word. But I'm not sure if, oh, that is it. I want to reload this. Okay, so I reloaded that now. So if we go back down here and we look at some large big word, right now, say I'm back in subword, I'm in the middle of it. If I hit meta delete now, it's going to go back. But that function's not available right now. Then I could do Control C WW for that function. It'd be nice if I could do it again after that. But I gotta get more. There's another package to do for deleting words, because I can hold meta down and delete it like that with a backspace. So that's another option, right? So I could just go, that's pretty quick, and then type my new word in there. But what I'm kind of what I'm looking for is if like you had ever used Vim or something like that, there's this change in word, so you could just do or change word. You could just change that whole word there. So I know there's like evil bindings for Emacs, but I don't want all of my Emacs keys to be mixed up. But I would like a key to say, okay, go to the beginning of the word, which is B, and then delete the word. Right. Delete the word, but yeah. So I'm gonna work on that. So okay, thanks everybody for joining today. We're getting close to that 100 subs. I do appreciate you guys coming along on my journey to learn C and on my journey to just doing a lot of computer programming. It's kind of just a unofficial, pretty laid back streaming channel where I want to program, I want to interact with the audience, and kind of just recreational program, enjoy programming for programming. Not a whole lot of AI. I use a lot of AI in my day-to-day work, but I feel like learning something by hand is kind of a lost art. So we'll talk to you guys later. Bye, everybody.